2005 Subaru Forester. This has a 2.5 liter turbo engine, and the complaint on this is there is no turbo. I have taken it on a test drive and I did verify turbo does not kick in. On items like this in our country, the first thing this car is getting for sure is a turbo. Now, do we have a turbo problem? Maybe, maybe not. Before we throw a turbo in this, we need to test without guessing. So let's do some evidence-based diagnostics. Now, the first thing I did with this is to hook up my scan tool, and I went with the owner on a test drive while I'm analyzing the scan tool. And I'm going to show you what results I got and what data PIDs I picked. Alright, just a quick one before we analyze our data. I just want you to note this is our current barometric pressure right now at the current elevation. So we're at 81 kPa. Keep that in mind. So we're going to take our fuel pressure readings: 1 at prime, 2 at idle, and 3 on a parked wide open throttle run. And I want to see my fuel pressure at least either hold or go slightly up when I hit the throttle on wide open snap. Because we have fuel pressure regulators here, I want to see whether my fuel pressure regulators are actually good. So that coming up next. We're back in the car and let's start our scope. Scope is started. First we're going to check our prime. That's a good prime, very quick. I like that. Let's start the car. Very nice, give it a rev. And let's pause that and shut that off. Now let's analyze what we have. Now here we can clearly see on a prime we are at 45 psi, and then when we start the engine it starts off at 44 psi, and at idle it settles down at 39 psi, and then when we give it a rev we increase to 44 psi. This tells me my fuel pressure regulator is working. And now let's see the pump pressure. Although just by looking at how quick we prime here, I've noticed that if you have a very quick prime, it shows you that your fuel pump has good life and it's strong. Just by looking at this, I don't think we have a problem, but let's go to the manual and see what our fuel pressures are meant to be. Here in the service manual, I normally look for fuel pressure by going to codes P171 and P172. So they normally give the fuel pressure there, because one of the things to do when you have a P171 or 172 is to measure fuel pressure. It's the easiest place I can see. It's the easiest place in these manuals to get the fuel pressure. So it says here, measure the fuel pressure while disconnecting the pressure regulator vacuum hose from the manifold. That simply means the maximum fuel pressure. And then the value should be 284 to 314 kPa, 41 to 46 psi. We have 44 psi when we rev and we demand. So that's at our maximum fuel pressure. So that's good. And then the nominal fuel pressure here, it says it should be 33 to 38 psi. And let's go back to our picoscope and measure at rest. When we are idling, we are exactly at 38 psi. So our fuel pressure is good. Right, so the car is running and I've selected some data PIDs here. Throttle sensor, accelerator opening angle, manifold absolute pressure, engine speed, and this is my tumble valve position sensors. Now they're given in voltages, and then this is the VVT angle, and then the TGV output. here is off and the TGV drive is open. Now I don't know what these two PIDs are, but first let's see what voltage we are at when we go on wide open. So I'm just going to do a brake torque. I want to see a couple of things. I know when I brake torque, at least I should be able to change my VVT angle, and then I want to see my accelerator angle opening. I want to see what the maximum is, and I want to see what my throttle position sensor voltage maximum is. So let me do that right now. So I'm in drive and I'm going to go to the floor. Now you don't want to do this to the car for a very long time. You burn up the transmission. Between 5 to 7 seconds is maximum. Alright, so what I noticed is my manifold pressure actually went to atmospheric pressure this time. Interesting. And I did phase on my VVT. Alright, so we're phasing on the VVT and our throttle is opening fully, and we know that fully open is about 3.9 volts. Now we're going to focus on this TGV and let's go on a test drive and see what they do when we go at high load. This should open. Alright, here we go to the floor. Right, it's the next day and I've had a chance to sleep over this, and I also wanted to find out how the TGV system works because I'm not familiar with it. I looked all over this manual, could not find the TGV system, but what I've noticed is Subaru have a different functional description manual from the service manual, and I do not have the functional description manual for this particular vehicle. No problem, I did some homework and I found out that the TGV system is simply for emissions. The flap in the intake is supposed to remain closed for the first 30 seconds or so after startup, and then it opens up. So I wanted to find out what our closed and open voltages are. So let me come here to control systems and go to engine diagnostics. Let me pull this a bit. The first thing I wanted to find out is my reading. So come here to Subaru Select Monitor, and here is where we have our data PIDs. So let's look for the TGV, and that's the position right and left. And look at this, it says when at idle you're supposed to have 0.44 on the right, around 0.48 on the left. And from what I know is that at idle this is supposed to be open, so my voltage is supposed to be low when open, and I can verify that by coming here to ECM IO signal electrical specification, tumble generator valve, but let me look for the sensor, the position. Let me just search here for tumble. Here it is, tumble generator valve position sensor. So fully closed 3.8 to 4.9 volts, fully open 0.2 to 0.9. We had 0.3. So that suggests that our tumble generator valves on both the intake, on both the left and right intakes are open, and they are supposed to be closed on cold start. So I just want to verify that. Right now the car is cold. I want to start it up and see what value I have on my tumble valves for both left and right. This should be closed, and then let the car warm up a bit, and then they should open. So here's our data, and right off the bat I can see that my TGV system seems to be working because we're at 19 degrees centigrade. But look at our TGV position sensor. Both the right and left are at 4 volts. Right now we are closed, and when we were driving they were at 0.3 volts. So I need to look away from this for now, but just to make sure. And right now my elevation is supposed to be at 81, 82 kPa, which we are at, atmospheric pressure. So let me just start the car now, and then we're going to focus on the TGV position. After about 30 seconds, that should open. Now we don't seem to be opening, so what I want to do is just to give it some throttle. That seems to have done it. So right now, from this data, our problem is not the TGV. Right now we are fully open, and you can see the TGV drive. Right now we are open. Okay, we need to look away from this. I can tell you the other thing I don't like is my fuel trim. If you notice, my fuel trim is negative 12.5 on the long term and between -1 and +1 on the short term. Why do we have a rich condition like this? I don't like where this is pointing me at. So let me go on another test drive, and I want to see the absolute load and calculated load. Now we don't have any turbo, so absolute load will not exceed 100%, but I want to see my calculated load go at least to 100%. Now calculated load and absolute load, they're a bit tricky, but what this is what the engine can output. If I see something like 51% here, it means the engine can output more and it's just not being allowed. If I see 100%, it means at my current throttle position and my current fueling, this engine is outputting its maximum torque. But absolute load, if this is a naturally aspirated engine, my absolute load should match my calculated, so it should go to 100%. But this is a turbocharged engine. We are force feeding it air, so we should be able to go well above 150% into the 170% percentile. So I want to see, I know I will definitely not exceed 100% because we have no turbo currently, but I'm more interested in my calculated load. So let's go another test drive and let me focus on that. I'm going to do a wide open gear 1 sweep, and I want to see what my calculated load will go to. Alright, those are very bad numbers. Our engine load only maxes out on the lower 50s, 51, 52, 53, 54%. That means we have an extra 45% at least of engine torque that we cannot achieve. Guys, this engine is just not moving enough air. If we are not breathing well, we're not going to produce torque. So we have enough fuel, our timing is fine. I don't like what our VVT is doing, but again, if you're not flowing enough air, those VVT angles, can they be good? Well, I don't know. Well, the fact is we are not flowing enough air in this engine. So we have one of two problems. Either our VVT has an issue, the VVT system, or we have an exhaust restriction. We know we don't have an intake restriction because we are at least coming close to atmospheric pressure when this engine is at high RPM. It's just that we are not able to flow that air properly in our engine. The other thing I don't like, to be honest, why do we have such negative fuel trims? Why are we running rich? If you're running rich, it means we have less oxygen than normal coming out of the exhaust. So what's happening here? This is pointing me to some kind of restriction in the exhaust. Trim numbers being way higher than normal in the negative side, having less than 60% calculated load, no turbo. I would like to check my exhaust for a restriction. So what I'm going to do is wait for this weather to kind of subside, because it's raining right now. Then I'm going to put a pressure transducer in one of my cylinders, the easiest cylinder to get to. I think it's cylinder number 2 in this car. It doesn't matter. And I want to take an in-cylinder pressure waveform, snap the throttle of this car, and see if we're going to build pressure in our exhaust stroke. So there's my pressure transducer, and I am in that cylinder over there. I have to remove the air cleaner housing, and when you're doing this, always make sure that you ground out your ignition coils so that you do not burn up that ignition coil, and you need to have it connected, otherwise the car will not like it. So our scope is running. The first thing I want to do is to come here, pause it, and I want to bring this line down here. And the reason I'm doing this is because this is a homemade transducer. Homemade transducers do not auto calculate atmospheric pressure. I'm trying to come up with one that does, but for now I need to understand that at different elevations I'm going to have different pressures. So right now I'm going to say that this line is my atmospheric pressure. Good. Now I'm going to start the car, and I'm going to let it idle a bit, and I'm going to give it a snap back to idle, and then we'll analyze. Snap. Back to idle. Okay, that's it. Let's analyze this waveform. Alright, the first thing I see is when we start the car, we do have a pressure buildup in our exhaust cycle. But keep in mind, this is a VVT system. So I see these a lot right at the end here, where you have a slight pressure rise when the VVT system is off. I don't pay too much attention to this, so I'm not going to make an issue of that. What I want to do, however, is to see what we have on a snap. So right here we've snapped, and I can already see an issue. Oh yeah, oh my goodness, this is my exhaust stroke. Look at the amount of pressure we're building in our exhaust stroke. Let me come here and go to the peak. So the delta here, we are building 6 psi on our exhaust stroke, and that's just in one cylinder. We are done. We have an exhaust that is restricted. So looks like it's new cuts for this guy. I'll give him the news and see what is going on. But this is not a turbo issue. This turbo isn't being allowed to spool up nicely simply because the exhaust isn't breathing well. So we can't move the volume of air that we need. And let me tell you why we're having negative fuel trims. The reason is this is acting kind of as an EGR system. When we build up this amount of exhaust pressures right here, we will inevitably close the exhaust valves while this pressure is in, and when we open the intake valve to pull this in, we are also going to pull in residual gases from the exhaust, and that will dilute our oxygen. It'll give us less oxygen, and consequently less oxygen going through the oxygen sensor is going to give us a rich condition. But this is a false rich condition, really. So when we pull away the fuel, we also are going to make this engine run not so well, and it's actually running a bit rough when it's at idle, and that's the reason. So seems like it's a new set of cuts for this car. Let me break the bad news for the owner, but that's it. Another one for the books. Restricted exhaust causing no turbo in this car. That's it. See you next time.